Yeah, hi Varta.
Hello, Subhash.
Um, there might be some confusion around the TSC meeting and this one, so not sure. Uh,
I think even TSC, they have some issues. I'm not seeing it's going. If you see the TSC chats, right?
yeah,
Chat, they are not at able to log in. I don't know whether
right.
today it had occurred. I'm not sure.
Yeah, not sure. Like for us, there is a no change in the time, except I think US folks. There's a change in the time. Hello, Tag.
Hello, hi guys.
Hello. Hello, Bim.
Hey, Subhash. This
It would
timing is a
seem,
bit of a mess.
yeah, the daylight savings timing change has caused a
Yeah,
lot of confusion.
Yeah,
yeah.
why can the world not agree on one timing?
Absolutely.
We
If
make
we are
life
going to
things so
change, we
Yeah,
should all change together.
Yeah, we make things very complicated.
yeah.
But maybe that's intentional.
I think this is
Maybe.
started in yeah. This is started since year 1800, I guess. Daylight saving, right? This
Yeah,
concept.
correct. Yeah, way before
Yeah.
we were born, I think.
Yeah. Okay, so we'll just wait for another couple of minutes, maybe just give, and then we'll start. Okay, we already passed 3 minutes, uh, and let's start today's meeting. So I'll share my screen. Okay. So today I have planned for these following points just to cover in today. Yeah, just to mention that today is the 14th of the March, and this is the work group 5 meeting. And as per our agenda, we have the 4 topics to cover. And yeah, again, it's like in the need basis, we'll go on those topics and discuss if time allows. So the first one around the observability update requirement discussion. So I got the update from Stephen that to account to particular topic. And the second one, NF to infra and the K form presentation. So that will be from the Vim. Yeah, last week also we had planned to give it, but unfortunately attendance was very quite low, so that's why we planned to this week. And yeah, again this week also we are seeing very less participant. Basically we'll record everything and folks can go through it. The third one, the user story discussion. So still, we can discuss on updates on it. Basically, I don't think we have much updates there. And the fourth topic that I wanted to discuss, the interest around the ML-driven assurance procedure. So just to initiate this topic because we are seeing some interest in the SIG one. So we could discuss on this topic also. Okay. So with this, I would like to hand over the control to Wim so that we can go through the NF infra and the K-form presentation and how it could benefit the work group 5 while we are preparing for the service assurance. So yeah, Wim. So I'll stop sharing, Wim.
Yeah, I'll share my screen. Yeah. Do you want me to? Let me. The presentation that I did in SIG 2 is broader than NF2 infra, so I skipped some, like the beginning of ports is not relevant, I think. So I started with this thing where we started with the objective that we had from the beginning, right? Is that okay? We can jump to other
Yeah.
places if you want, right? I also not sure. I mean, I can discuss K-form, but I think for the use case that you have, I'm not sure whether it's needed. But okay, let's at least discuss, right? So
Yeah.
when we started NF2 Infra, what was actually the thing that we were trying to solve, right? Is that today in a network function, right? So I call this left side the black box approach, right? So although we manage this as a closed system, you typically see that each of these elements like security, networking, hardware, host, application, this was all dealt with internally within the application, right? Now, when we move into the cloud native space, right? So all of these things, instead of this whole black box, right? What the vendor actually delivers, I call it the app, right? But all the surroundings like the host settings, certain hardware requirements, certain network security, and that is more than this, right? Is kind of coming from the, let's call it infra, right? So that's why we call it NF, right? Which is very specific to our world. So I typically call them apps, right? Whether it's a network function, it's more heavy on networking and hardware. But at the end of the day, we are an app. And so the problem that was highlighted by a number of the SIG1 people was, okay, today what happens? And even if you look to what we do in R1 and R2, we even do this, right? So we kind of, a human today figures out all the things that this app requires and sets up the cluster to accommodate for it, right? But it's kind of it's a manual job, right? And what we typically see is that there is a bunch of requirements that are not really well specified. So meaning people forget it and then they have to reverse engineer and stuff like that. So the feedback was so there's a lot of hidden requirements. So there's things that are forgotten. It's a huge manual effort, right? You see conflicts because of course the application and the infra are typically separate people. And so all of this is complicated. And the idea when we started was, okay, what can we do to improve this, right? So that was kind of the starting point of NF2 infra. Now, what we always said is that we wanted to honor the KRM and the API-based framework that we were starting with Nefio, because if we can describe one way or another through the KRM resources, the requirements that we have from an app towards the whole, let's say towards resources, right? Or towards things that we needed. So for example, a use case is like, we need to install today like the GTP kernel module, right? So today we do that manually, but if we had a system by which we could express through a KRM based system that we needed that and someone is going to act upon it, that would already solve one set of problems, right? Now, what you then also have to deal with is, what people also wanted to have when we were talking about NF2 infra was, they wanted to start from, hey, I want to deploy this network function. And of course, these requirements were there, but nothing else. So the system ideally would automate all its dependencies automatically, right? And that's very similar to what you want to do. I think in service assurance, you want to, for example, deploy an actor pod, right? Based on a service assurance requirement that you put in place, right? So that's why there is a link there, right? And of course, you could do more, right? So we could also look at placement and scheduling and where things were going, right? But we kind of focused initially on, okay, what do we do? What system do we put in place to tackle this particular problem, right? And then we kind of said, okay, we somehow need to, on one hand, discuss these requirements or have a way to express these requirements, right? Which is basically the desired state. We need to look at what is actually going on into the cluster, right? And what was also important is that, okay, although we wanted to fully automate it, it could be that for certain things, there has to be a manual approval to agree or on certain things. And that would then be used inside of the framework to report upon the status of that particular thing, right? And yeah, so that's kind of what we try to accomplish, right? Now, for the base things, like I take an example, so and maybe I'll skip this for now, right? But
could we take a question?
Yeah, sure. Yeah, go ahead.
Okay, yeah. So yeah, I just wanted to understand how dynamic is those requirement, and also how actor knows like to realize the requirement, how exactly that logic comes into the picture.
Yeah,
In the actor, yeah.
Yeah, so this is actually a good picture in my view, right? On it. So think, so there is two, by the way, what I figured out is there is two sets of dependencies, but I think the one that you need is what I call static dependencies, right? So today what we have, right, is, let's say an actor pod will have most likely a CRD, right, in which it tells what APIs it offers, right?
Okay.
So think of, so there will be a package. Let's call this the actor pod package, that actually has what I call an API is actually a CRD. Okay, so you build an application that which is your actor pod, right? And you actually also say, here is how you can consume me, right? Through the CRD, which is what I call API. There is other ways to say that, but in the simplest form is the CRD, right? Then you have a service assurance package, or it can be a single element, right? That says, okay, I want to consume this API, right? So this is your requirement, your service assurance manifest will at some point, so we want to instantiate this, and you call this, right? Now, with this system, because we know, and this API is predefined, and this KRM is using that API, we actually know through the installation system that this package or this pod is actually running in that cluster or not. And if it's not, we can actually trigger the installation. That's kind of what I showed into the demo. Because we know that you want this requirement, which is basically the service assurance. You want to basically say to the actor pod, I want these requirements to accomplish, and then he acts upon it by leveraging, or you are going to say, okay, I want to use the API that he has defined, right? We actually, and by knowing that this package is owning that API because it has a CRD inside, we actually know that this KRM is depending on this. And based on this, we know whether we can, if it's not running, we have to install it.
Yeah.
You see, does that make sense?
Yeah. So second part, what I would like to know, suppose let's say example, we deployed the UPF, okay?
Yeah.
So, and in the second phase, we also would like to create some service assurance
Yeah.
on that UPF. So how exactly we'll do in a management cluster? Because in management cluster, we won't be having those APIs, right? Exposed,
So
right?
the packages contain those APIs, right? So
Right.
so what happens? So what I did, when I showed the demo 2 weeks ago, right? So that's why there is a discovery controller, I call it, right? What it actually does, it actually looks at all the packages and figures out all its dependencies that they have with each other. So if you have a package, which is basically your service assurance requirement,
Mhm.
and you will say, I want to deploy this on this cluster or this network function or whatever, it doesn't really matter. We can figure out now whether all its dependencies are actually there. And based on that, we can make decisions, right? So what
I see.
happens, for example, if you say, I want to deploy this service assurance on this UPF that is running in this cluster, based on all the dependencies that we figure out offline, right? We now know whether or not your particular thing that you are depending upon is actually running and can establish or can accomplish the implementation of your requirement.
Okay. So
You
if I
see? So in other words,
Mhm.
so what's happening, if you look to what the demo is that I did, was the following, right? So we have packages, which what we call is like catalog or whatever, it doesn't really matter. There is something that offlines, so at the back, right? So it's running all the time, and it actually figures out all the dependencies between all of these packages, right? And so that's what I call this static dependency. There is also runtime dependencies, but for your use case, I think static dependencies is sufficient. So in other words, by figuring that out, so it also works, for example, purely with the network function, because today, say, for example, we need NF deployment, right? That is the unit that we schedule, right? So that is basically this. The
Okay, yeah.
package, so today what we do, we pre-deploy all the CRDs and stuff like that. So today we actually put all of that in the workload cluster. Whether we
Right.
need it or not, we just put it there, right? Because we know that's what we are going to schedule. But with this system, we don't even have to do this anymore, right? Because what will happen, and that was the demo that I showed last week or 2 weeks ago, is actually you basically instantiate the top level thing that you wanted. And if you have 10 dependencies or 10 packages that you need in order to accomplish your upper goal, the system takes care of all of it.
Mm-hmm. Okay.
You see? So the demo that I showed was basically this. So I instantiated this, and the system, so this thing needed Cert Manager, needed Copy Core, needed Docker, needed Control Plane, so all of these packages, and they were auto instantiated even within its dependencies. So we first did this, then these will happen in parallel, and then this, because the dependency tree was like that, right? But this happens, for example, if these things were running inside of the cluster, the installation, so that would not be triggered, right? But so with the system, we can, although we called it still NF to infra, it basically it's now a generic building block that we can use for anything. You see?
Got it. Yeah. But Wim, there's a chances of conflict in KRMs also, right? Let's say there are 3 package and each contains the same kind of KRM. So that conflict may
That's not the
arise.
problem. What is important is that the API is only owned by one person.
Mm-hmm.
And that I think is very easy to do, because it's the CRD is typically owned by one thing, right?
Okay.
And actually, the system will sort it out, by the way. So with the discovery thing, will figure out that this rule is not met.
Got it. So yeah, if I understand correctly, so in the UPF package, we need to inject service assurance.
No, you don't. You can. This can be a separate package. It doesn't even have to be inside of the UPF, by the way.
Yeah. No, this is the highlighted thing where the KRM is there. So that is the actor pod, right? So because
No. So this would be your actor pod, which
Mhm.
basically your actor pod will have a CRD, right? Which says this is your service assurance CRD or whatever CRD you put, right?
Okay.
And this is basically uh, what services this package offers to the rest of the world, right?
Right. Okay.
And then you have another package probably, right? That can be part of the UPF, but can also be independent, right? That you say,
Right.
I want to do service assurance on this UPF. So you schedule this for that UPF. The system will figure out where that UPF is deployed, and it will say, okay, is this component, this software component running in that cluster? If so, it will install it, and it will not instantiate this package unless this is done.
Okay. Got it. Yeah. Okay. So either the UPF package has the KRM, otherwise
Or
independently we
correct.
configure the
Yeah.
KRM to figure out the UPF and use the API from the actor, right?
Yes. So what this KRM package, it can contain more, right? So that's why I just highlighted one of them, right? So, but your config for the actor is contained in a package, right? I don't care which one it is.
Okay.
And once you schedule this instantiation, the system will figure out whether or not this software is available to accommodate for this KRM, and this will only be instantiated when that requirement is met.
Okay, Bim. And the second part, what I wanted to ask for the second user story where we do impact analysis. So there we would like to create the hierarchy of the resources.
So
So
I was discussing with, so the hierarchy is basically done, right? So what I have been discussing with Bernard in parallel, right? So what I did is, okay, I didn't have it here into the slide, but the way the system works, right? So I express these dependencies that I figure out, right? So we I can share the thing that we discussed, right? For each package, right? So there is actually two sets of dependencies, by the way. So for your use case for service assurance, you mainly need what I call the static dependency. There is also runtime dependency. Okay, so runtime dependencies is, for example, I need this specific, let's say, network instance or namespace to be there before I will act, right? And so in a package has basically a static package, which is a catalog package. You don't know the parameters that are being consumed by it, right? So static dependencies are resolved without understanding the full parameters, right? Because here you say, I want to use this API. So whether this is what parameters this API request is not relevant to know the dependency between this guy, right? But there are also runtime dependencies, but the way that we describe them is the same. So there is just a type between static and so on. And per unit that has dependencies, we express them within the CRD. So for example, in the package, what I did for the static dependencies, in the status, those dependencies are, let's say, reflected as part of the package revision. So in its status, you actually see this package revision is depending on these other packages, right? And by having each of these individual, because in order to do this, I actually built a DAG, right? I built this dependency tree. I actually built inside of the scheduler reconciler, right? Now, for, let's say, other people to consume it, I don't believe that Kubernetes CRDs are the right way to express the tree itself, but what has to be expressed is each individual component and what its arrows are that it's depending upon. And by doing so, it's very easy to build this picture. That's kind of what we discussed with Bernard last week. is having on a per unit, whether it's runtime or static dependencies, the system is the same. You have a way to express the dependencies that this entity has expressed, if you will, right? That's what we are going to expose as part of a CRD. And with that, you can build all the trees, all the whole system easily.
Okay.
Does that make sense?
Yeah, understood. As example, like a runtime dependency where we don't know about the networking in the workload cluster. So that only we understand at the
Correct.
time of executing it,
Yeah,
right?
of instantiation. Yeah, of instantiation.
Yeah.
So, for example, K-form, right? So if we go to K-form, builds a runtime dependency tree.
Yeah.
So that will be then. We don't expose the full tree, but we expose the individual, what we call the vertexes with its edges, right? Every vertex with its edges that we would express. And by doing so, building this tree becomes easy, right? Because you know each unit, what its things are, and you don't, you also actually say the entity that you are depending upon. The difference between static is you can do it offline, whereas runtime, you have to do it when you instantiate.
Okay.
Right.
Okay. Right. So, Wim, is it possible we export this dependency graph outside so that the higher level service assurance loop could take a benefit out of it? So, or impact analysis.
Yeah. So that was the idea, right? So the problem is that what we discussed, so the problem is that CRDs are not a very good way to express graph, right? So what we want to express is actually each unit, right? Or each entity express its own dependencies. So, and by doing so, the building this tree is very easy, right? So, for example, what I'm doing right now in the NF2Infra software, right? That is the discovery controller, right? Which basically discovers the package and its dependencies. It actually it builds. So it builds the dependency graph, right? No, it doesn't build the dependency graph. It builds all the dependencies of an individual package, and it exposes that in the CRD status, okay? So what it basically does is, for every package, you actually know all its dependencies that you have, right?
Okay.
Now, if you do so, the scheduler is just using that information and building this graph, and that's basically just building the DAG. And that's kind of 10 lines of code or something. And then you have this tree. You have this tree, basically.
Create it one by one, right? Yeah.
Yes, yeah. So what you do basically is, you have to go to the packages, right? And then, you basically, and then you basically add them to the DAG, and you say it's an up or down vertex, and then you get it, right? So it's fairly straightforward to do.
Right.
And that's, I think, serving the problem that Bernardo is trying to resolve, right? You can then see, okay, each of the entities, who is depending on what, and so on and so forth, and as such. And now we have a generic system that we can leverage for various stuff, right? That's, I think, the important thing.
Okay. So, Wim, this feature is available. Otherwise, we could also involve from the workgroup 5 to work on it.
I need to release the software, but this is implemented. All of this is implemented already.
Okay.
But we can, of course, when I release the code, you can have a look and see whether you want to improve or stuff like that. Yeah.
Sure. Yeah.
But all this is when I showed the demo, it was basically, I'm just going through the process of getting it out.
Okay. So the code is not yet out, right?
The code is, so I just need to wait for approval within Nokia, but the code is not yet in Nefio, if you will.
Okay. So at least in your private repo, anywhere, I mean, like a GitHub,
we have, but it's at the moment it's in Yeah, in the Nokia private thing,
I
so
see.
it's not public yet.
Okay,
But
okay.
yeah.
Okay, thank you. Yeah, please go ahead.
Yeah, so
So
that's kind of it a little bit. Kform is a component to help in the whole process, by the way. So that's a little bit of a different thing, right? I don't know whether you want to know about that.
maybe some introduction if you could give so that we can understand these concepts also.
Yeah, so Kform is a bit, I mean, it's an alternative way to do what we are doing in KPT, by the way, right? So what yeah, maybe I can, the easiest thing is to show a demo. I don't know, were you on the, I did a demo in the SDK meeting. Is someone there or not? So you haven't seen it, okay? Probably not.
No, I was not there in this ticket.
Okay, so let me, what I was doing. Actually, I just built a VS Code plugin for it. Where are my examples? Here. Yeah. So if you look to, I'll start very simple. So I basically build a runner of Kform inside of VS Code, right? So the way I'll start with a very simple thing, right? And I did the example is very simple examples. But for people familiar with Terraform, Kform is actually what Terraform at the end of the day is, but Kform has two things that are making Kform unique compared to Terraform. Is that one is the state of Kform is in the cluster, right? So you don't need it to be, it doesn't have to be in the cluster, but there's no state because the state is actually inside of the cluster for us, right? Because we use Kubernetes to store them, right? And then we have the other thing that I did is Kform is 100% KRM, whereas Terraform has its own schema definition to build APIs and stuff like that. So here we just leverage KRM as is. So in its simple form, what Kform is, so you just have what you see here. So this is a package, right? So forget in and out, right? So the package, I just create a very simple package. And this is kind of the resource that we are talking about, right? So how Kform works is basically, if you don't do anything, we just render this as a native output, okay? Now what
But
you
Phil,
can,
it's a different from the KPT package, right? If I understand correctly.
yeah. So so for me, this is a package, right? But there is no, you don't see KPT files and stuff like that. It's all gone, right? So there is no KPT file. So for me, it's just a package for me is KRM, and then you can put some, let's say, what you see here, what is specific to Kform is these annotations, right?
Mm-hmm.
So Kform has very similar to Terraform, by the way. So that's what I stole from Terraform, if you will. In Terraform, you have input. I call it input. In Terraform, it's called variables. So you have variables, right? You have output, which is output. But for me, an output is if you don't specify anything, it's an output, right? So you don't have to annotate it with anything because it will be an output. And that helps, for example, if you take a software thing like the demo that I was showing, like Cert Manager or something like that, right? If we take software from the internet, right? And you don't want to do any specialization or whatsoever, you just take it as is. You don't have to do anything, and all of it will be rendered by Kform without any change. Whereas when you have a KPT package, you have to make a KPT file, you have to put stuff there. So you basically have to basically change the content to be able to make it a KPT package. In Kform, you don't have that, right? So it's basically native KRM. If you don't do anything, everything is output, which is the default. But then you can change certain files or certain input to have another meaning. So for example, a block type is actually also what Terraform uses under the hood. You don't see it, but that's what happens. And so I have different block types. One is input, which is basically, this will never be rendered inside of the cluster. And so you also don't have to do local blah or something like that, right? So this is just an input, which is a resource that you can use to basically customize something, right? So for example, here I'm using it to say, okay, cluster name. So by default, if you don't do anything and you render this with no input, then here is my runner, right? So what you can do with the plugin is basically select the package, which is example one, right? And you can say no inputs and no outputs, right? And then what will happen is this guy, there will be a K-form channel, right? This does not work. No. Output on the file.
So it's
Wait
a
a minute.
VS Code
So
plugin, right?
yeah, I
Yeah,
created a VS Code plugin to make it's easier to do the demos, but I need to
Okay.
go to the extension, the settings. Wait a minute. So where is it? I think yeah, see, my default is, so you can output it. So I put my default into, so this is what is rendered, and this will be put to the cluster, right? So how did I got to that result, right? Is that what you see is that input.context 0 is actually referring to this element, right? So that's also how Terraform works. So you basically input.context, which basically is input. The name is context, but if you put a resource ID, so this is now duplication, but you could basically make this example or something like that. So input.context is the name, right? And then what happens is you take data.cluster name element. So here you see data cluster name example, right? So that's basically, this thing is substituted with that information, right?
Okay.
And what you see is that, yeah, then you get this type of information out of it. So you see that each of these things is resulting in a mutation of these variables that are being substituted, right?
Okay.
Now, right, so that's kind of what Kform does. And I showed here a very simple thing, but you can have 20 resources in here and it will sort out the dependencies and stuff like that. And it will do all this rendering and stuff like that, right? Now,
Wim, so I have one question. So how it is different from the Helm chart? There also we refer the values.yaml to fetch those values, right?
so here it's, you could say this is a fully open KRM, because in Helm charts, what you do is you basically hide the internals, right? So first of all, you don't create an API, right? Because your values.yaml is not really a structured input, right? Here, all the input is KRM, so you have a definition of this, right?
I see.
But you kind of, you're right, is that this is kind of Helmish, right? But a very open Helm thing. So because Helm is closed, right? So internally, Helm does a lot of stuff internally, which is kind of hidden from you. Here, it's an open Helm, if you will, because you can, anyone can do these type of substitutions, right? So I also have, for example, conditions or iterators, right? So you can basically build a multiplier and stuff like that. So you have all of this logic inside of the system, similar to what Helm has. So you're right, is that it has very similar attributes than Helm. The difference is that it's fully open and everything is KRM focused. So values.yaml doesn't really exist here. You have input files, but they are structured data because it's KRM.
Okay.
Right?
So Wim, if I understand correctly, so basically in your package definition, you need basically the input file and
Yes.
like a template, which in this case is a workload cluster example, right? So
Yeah.
in the input, you define in annotations what you want to replace in your template, right? So it's
So look at Terraform in general. I think you're probably familiar with it, Victor, right? So Terraform. Yeah. So what you have variables. So input is the same as variables, by the way. Okay.
Mm-hmm.
And then I don't show it in the demo here, right? But then you You can have resources. I also have resources, which is basically create or apply this resource into the cluster, right? I have an object called data. So if you make here a block type resource, right? You have to specify a provider. It will actually, so it will be a Kubernetes provider. So it will actually go to the cluster and apply this config map to the system, similar to how Terraform applies it to via provider to the system that the provider interacts with. You see?
Oh, okay.
So it's very similar from a structure point of view. So what you do, now I'm not saying that all the packages need to do that, right? But when you structure a package, so each of these things is like an entry in the Terraform file, right?
Mm-hmm.
You see? So now you can, what you can do is, in Terraform you have variables, but you can also, for example, you could say, get this config map from the cluster. So in this case, the data type would be data. You would have to specify a provider. So it will fetch, so you probably don't specify this. You fetch this data from the cluster, and then you can use this to actually do the same substitution here. So that means that the data that you now use is no longer coming from statically within the package, but it's actually, it's what John wants to do with the Redux, right? So if you look, I want to inject a resource from the cluster or from a package. We just have to specify this within the package itself, and it does it for you. You see?
Yeah, yeah.
So the difference is that it's very explicit, right? So that's what I think is, if you look to KPT, it's kind of an implicit system, right? Because in KPT, you say apply a replacement, right? And you have to look into another file to say, okay, what did I replace? Here you actually see this value. So like say you have to do set namespaces, right? You basically say, here is the namespace I'm going to put, and you know where you put it, right? If the namespace was somewhere inside of the KRM, you can still do it. Whereas with KPT, you will have to change the KPT function to make this namespace known within the namespace function. Here, you just put the namespace somewhere over here, right? So it's a more explicit system, right?
Yeah, that what could be very useful. I mean, maybe for another demo, could be like to use the example that you use, for example, like the KPT file apply or like taking,
yeah,
and how that could be done in your keyform solution.
Yeah, correct. I have examples of all of this, Victor, right? But so in other words, I've built this system, right? I have been able to replace all the specialization with just kform files, no code. I mean, the code you have to write is this.
Yeah, which is more easy to understand. And
yes, I think it's much more easy to understand, and way more people will be able to consume this, I think. But yeah, so that's Kform. I'm not saying that Kform is the only way to do it, but I think there are some, I think, advantages that I see personally about it, right? But for example, I mean, what I'm doing with the plugin basically here is you can select a file, you can say, make this input file, right? Instead of the default that you have here, you can put that, right? And then you can also, for example, say, spit it out in this directory, right? So it ran, right? So now you see, this is the claim that would be rendered out of this kform loop, right? So I say the input is H1 and revision 3, right? So now I got revision 3 and H1, right? But so, and you can do all, so other examples are, for example, here, but I use the same syntax. So here you basically do a count of the input that you render, right? So here you say, I want to render this thing X amount of time, right? So I want to say, here I put 10, okay? So what you do, if you do a run, I just select example 3, right? So basically that's the input. I put input from it and I say render it out, okay? It's done. Here you see 10 files, right? So 10 workload cluster, each with their own specific data that you have specified, right? You can also do conditions, right? So all of this stuff is kind of there to make. So here this is, for example, a condition, but the syntax is the same as Terraform, by the way. So you basically say you do a count. The way you do condition is it's a count of 0 or 1. If the count is 0, this will not be rendered. If the count is 1, you render. So for example, if attachment type of this input is VLAN, I would render it. If not, I would not render it. That's what this does.
Wim, how you handle the input for the dependency? Because let's assume that currently it is a single resource, right? Then you need to resolve the dependency. So the new KRM will come into the picture, and again we should have those inputs available to us, right?
Yeah. So what happens? So now Kform also is interesting. So what is good here? You see, I do pure client side. I don't need the cluster to test anything, right? So I can do this offline to see whether my logic works. Now, if you look to the demo that I was doing 2 weeks ago, this input came from the package variant. So I said, I want this cluster, right? So these parameters came in from the package variant. So when you schedule a package variant, you say, I want to run on this cluster and I want to set this parameter and this, and I want this particular version of Kubernetes for this cluster, right? So this is input that you get. So I can get it from a package variant. I can get it from a fetch that I do within a cluster, or I can do it offline for someone who tests it, right? For me, this is a mechanism to get that to you. I don't care how you do it. I give you all the options, right? It can come from within the package. It can come offline as you see it from another directory. It can come from a package variant that gives me the context. I wanted to build a generic framework that has flexible inputs and outputs, because I'm not sure whether I need to care about instantiating the result of Kform, right? At the moment, I have something, but I'm not sure whether I need. So in the demo, for example, that I did 2 weeks ago, I just generated a package and I said to config sync, here is the package and here is the output, go and deploy, right? So I didn't do anything for installation myself, but that's again optional, right? So I wanted to focus Kform on the bare bone of mutating and transforming data and fetching data. So basically do what I call the transformation objects that you need with certain, let's say, parameters that you get from the system.
So we in the chat I just placed a question. So I just mentioned because there is a link. So what you're saying is usually in KPT we have to use these set values YAML where usually there are some
apply replacement,
exactly.
All of that. Yeah.
So basically with Kform, what we are going to do is we're going to avoid this kind of scripting or complexity. Okay, got it. Thanks.
Yeah. I think even in my view, so Victor, that's something we have to look at. In my view, the installation even that we are doing, some of the scripts that you have, you could actually use Kform to do some of these things.
Yeah. Yeah, because in that way, I can keep, for example, like when you rely on the name of the folder, like a certain name of the package.
Yes.
Okay.
I'm trying to get this out of the door ASAP, right? Because I think it's important for people to experiment with it. It's going to be perfect from day one, probably not, right? But at least I think it's good to get some feedback upon, right? That's why I also created this plugin, because you can do a lot of development outside without really having an online system, which I think is also a big advantage, right? Because you can develop it outside, right? You just put some KRM inside of here, right? And that's about it, right?
Actually, something similar to this project I saw in our own app also, the project called Controller Design Studio. So that Alexis was driving it. So maybe I'll post this link here.
Okay.
So yeah, it was trying to resolve the parameters at the runtime when you deploy any Caesar package. So it was trying to resolve those parameters. So yeah, this also could be something similar. So maybe you could also check it.
Sure. The other nice attribute, by the way, that Kform has is what I call, so in Terraform they call it modules. I call it mixins or packages, right? So you could render this with another package, right? So in other words, so it has inheritance, if you will, right? So for example, the use case is, so we have a function for IP addresses, right? We have a function for VLANs. We have a function for NADs, right? Each of them could be their own individual packages that basically render NADs and interfaces and so on. And you can actually use them. So instead of saying, I'm doing it locally within the package here, you can call upon that mixin or that other package that is taking care of VLAN creation, for example, right? Or VLAN allocation. And so you can render it. So in other words, these packages now also can become hierarchical. So that means that you can build very reusable building blocks that can be inherited automatically, you see? Which is also a very nice attribute, I think.
Where exactly you're doing inheritance, Wim?
So for example, one of the resources that Kform has is what I call a mixin, right? So block type mixin. And what you do with that is actually, we can call, it's actually calling another package, right? So if you put that resource inside of your package, you actually fetch. So if you do it client side, right? Within a cluster, it's not a problem because the packages will be there, right? Because the fetching will be through ports, right? Or the equivalent of it. Whereas if you do an offline run, right, you have to kind of fetch that package. So I also built a system. So I use it I use OCI as my backend because you can do signing of this packages. So what I do is if you add a type mixin, which in Terraform is called module, you can actually indicate the source, so which version and stuff like that. So what will happen is if you do so, I will download that package from wherever the place is that it's located, right? And then I will, as part of the DAG execution, so when that node that you execute this particular module is going to execute another DAG, that's that package set, and it can be hierarchical. So you can basically chain things, right? So you now get like a dynamic execution of things, but the nice thing is that you get reusable code. So in other words, if I need a package for IP addresses and VLANs and stuff like that, and I need it also here and here, you can just reuse that package without having to duplicate the code. So similar to Terraform modules, by the way.
So Wim, one question about this particular approach. So does this mean that if we adopt this particular approach, we have to abandon what we have in KPT, or can they coexist together?
They can coexist as well, right? So of course, so for example, one of the discussions that I had after the call with Isti, because Isti, he's not here, but he also, I didn't know the details. So what you could do, for example, you could do one pipeline with Kform and the next pipeline with KPT. But Kform will basically look at KPT files as if they are regular KRM, right? So for me, it's like a KRM thingy. So I will, if you don't annotate it, it will be output. So for example, what you would have to do if you would run Kform and KPT together, what you would have to do is probably run Kform first and then KPT after, because KPT will then do all these annotations and stuff like that. So we need to figure it out, but they can coexist.
Okay.
Okay. So any other question?
Now I took
Okay,
the
Wim,
whole
please
hour.
proceed.
Sorry about it.
Yeah, please proceed, Wim.
It's okay. Yeah, I think I'm done. I mean, I have more, but I think I got the most basic stuff out of it, right? So I think that's kind of
Yeah. I think, yeah, it was really nice introduction. It's like we are seeing some possibilities. The first part where we were placing the workload, right? So that seems like could be resolved. So as a next step, we will try to bring this aspect in the user story, and maybe you could review it.
yeah, I will
Uh,
review it. I will review. Yeah. And I'll
yeah,
also get the software out of the door basically
yeah,
when you can have a look.
yeah. I think it solve many problems actually. I
Yeah,
feel.
I think. See, if I'm honest, it's not because I'm doing, but I think it solves a bunch of problems. I agree. Yeah. So because it's not only it actually solves all the dependency management. Not all. There will be still other dependencies that we don't resolve, right? But
Yeah,
for example, installing all the software. And so today, I mean, Victor, we install Multus, we install a bunch of software ahead of time. But with this system, you don't have to do it anymore. You basically say, I want to deploy this thing. And if he has an NED and he needs Multus, the system will install Multus, basically, right? So that's one. I think also the hardware-based dependencies, right? So if we build an API on top of these resources, the system figured it out. I think it's a very nice property, and it's solved in a generic way. But to be honest, this is the value of KRM, right? This is actually one of the value proposition that Nefio brings to the table. If we standardize on KRM, this is possible,
yeah,
right?
yeah. Okay. Thank you, Wim. So we have another 3 minutes. So any questions before
Right,
we move to close the meeting?
right. Yes, yes. So it'd be interesting if you make use of this NF2 infra concept inside your user story, Subhash.
Yeah, yeah,
But I honestly think, service assurance, though it may have dependency as an English word, there it's a different ball game, right? Like depending upon the intent, I need to place it in the proper cluster. That
That we
type of
solve, I think, Verada. That we solve, right? So the installation is thing. I believe that service assurance will have to use the runtime dependencies that we are talking, because installation is, I think, we cover, right? That is not the problem. What service assurance still needs to do is all the runtime dependencies that we handle, right? It needs to use to actually do its service assurance job, right?
correct. Yes, yes. Not just like that. There are other types. But anyway, like, since we are running out of time, package dependency, yes. Where we place the actor, yes. In fact, Subhash,
Yeah.
we have to replace it using the NF2 infra. Just put it as a black box, right? In our use case story. But there are also other things like, depending upon the intent, where to place the package itself, not the package dependency. So those have to be from SA controller or some sort of stuffs.
I think Vardha, that could be a requirement to NF infra so that they can offer those kind of features also seems like to me.
Yes, I think
Right,
so
right.
too.
Yes.
Yeah, you basically have to say, I want this to happen, and then you delegate, and then the other thing will take care of it. Yeah.
Yeah.
Right, right. Perfect. Yeah. So let's do some sort of utilize this concept now that we know this, and redraw the use case and probably the requirement and discuss in the next week.
Okay.
Yeah.
Yeah. Thank you. So okay. So already I think we are reaching to the time. So okay. Let me share my screen back again. Okay. I hope it's visible. So yeah, so one more topic we wanted to cover today, interest on ML-driven assurance procedure. So actually, we are top of our. So let's cover this particular topic in the next week because it requires a lot of brainstorming, what people think. So we could go on it. Okay. So we'll keep this topic for the next week. And with this, actually, I would like to thank you, Wim, for giving us knowledge about the NF infra cave form and helping us to shape the user story. And yeah, thank you everyone for joining this today's meeting. And let's meet next week once again back. Thank you. Thank you,
Yeah,
everyone.
thanks.
Thank you all.
Thank you.
Thanks.